instead of I not finished yet. So everyone can hear me?
Yes, yes.
Okay. Okay. Thank you. Okay. Without wasting any more time, because I got only 1 hours before 3, but I got around 67 slides. So we need to go fast. Okay. Bismillahirrahmanirrahim. Okay. Today my title is about toward effective string-based test case prioritization approach. So this presentation today will consist of 7 chapters: introduction, review, methodology. Okay, 3 result enhanced string distance for TCP, enhanced string distance plus applied firefly algorithm for TCP, enhanced string distance plus clustering technique for TCP. So the last one is conclusion. So introduction, software testing has been consumed long time for execution and become more expensive. So TCP appeared to enhance test variability and in software testing activity. So there is numbers of TCP approach available and string distance or string based approach show a promising improvement. So what is TCP? Actually, TCP is first mentioned back to 1997 by Wong, and the goal is prioritization is to maximize early fault detection. So based on the table example shown before this one, so it is clear to have TC5 and TC3 to be executed first in order to detect all the fault at earlier rate. So how TCP actually works? So TCP start with the preparation of targeted data, and then we determine and calculate and measure the prioritization criteria. Then we prioritize the prepared data based on the measured criteria. Oh, sorry. And then we monitor and calculate the performance of complete TCP process. So what TCP utilize? So basically TCP utilize everything within the software development process, where we have the requirement phase and then coding phase, which is source code, and then testing, test case, and finally we got fault or the history of the testing. So every single different software changes stage in TCP have their pro and cons. For example, if you utilize requirement, it uh, can classify the crucial test cases related to the requirement. But to have a mapping in multiple stage may not remember, means that we need to map the requirement changes back to the straight to the test cases, because we need to prioritize the test cases. So for the source code, the majority of the bugs and fault normally come from the coding. So coding, but coding also could be a problem interesting. And then the test cases, the TCP itself refer to the test cases. So if we consider the test cases changes, should be okay, but not all changes in requirement and code resulted in test case changes. Means that if there is changes within the code or requirement, sometimes the test cases does not change. For our history, the pro is we can possibility have a higher possibility to detect specific fault at higher rate, but such information is not quite available for every software, because also not all changes in requirement or code resulted in fault or history change. So similar to the test case. So the research gap is the first one is TCP approach that does not adequately address on continuous changes. Conventional TCP approach tends to work on full suite of test cases, which does not compatible with current trend of software development, which is have constant changes. Therefore, we need to require an approach which can specifically address on targeted test cases. So gap number 2 is existing string technique highly dependent on single metric. Existing string technique have shown promising fault detection capability, but string technique applied within the approach are highly dependent on single metric. Therefore, we need to make an enhancement for the string technique. And gap number 3 is existing prioritization technique used in TCP approach to tend to face out optimal prioritization suite ordering. The problem arises in existing prioritization technique, signifying the relevance of exploring alternative technique. So alternative technique also need to cater the targeted test cases where existing technique does not, which is back to the gap number 1. So therefore, the additional technique will require to cluster or select the targeted test cases. So motivation from the systematic review made for a string-based approach, existing string-based has shown promising for detection rate, while uses of single string metric can be improved by adding other metric. The uses of machine learning in recent work show have higher effectiveness, also have low performance on coverage result. The uses of swarm intelligence also give a significant effect to CCP process, yet still require tuning for string-based technique and approach. So the last one is to have a formal defined method, especially in tuning machine learning and swarm intelligence into string-based approach was to be addressed. Okay, from the gap motivation and come with the problem. So the research area TCP, and then we got three research gap: TCP approach, string technique, and partition technique. For string, we suggest to have to go for a string-based TCP approach, where the problem is how to tune approach to address on targeted test cases. For string technique, suggest to improve by adding other metric. The problem arise is what is the other metrics table to be enhanced together. And then the prioritization technique, we split into two. One is clustering technique, and to tune the clustering technique to with enhanced string, and then prioritize the cluster, then tune the prioritization technique with the enhanced string. So problem statement is how to effectively cluster and prioritize the test cases through string-based approach using software changes. So research question, what should be enhanced to string distance in order to ensure that string distance have sufficient enhancement to increase fault detection rate? Research question number 2, how to tune clustering and prioritization technique together with enhanced string distance to improve fault detection rate and coverage effectiveness in TCP. RQ number 3, how to apply the proposed approach systematically into testing environment based on software chain in order to improve the effectiveness of TCP. Research aim is to propose and evaluate an enhanced string-based TCP approach with integration of clustering and prioritization technique. Research objective to propose and evaluate enhanced string metric in test case prioritization by combining string distance and its weight-based metric to increase fault detection rate and coverage effectiveness, to propose and evaluate clustering technique in line with prioritization technique using enhanced string metric to improve the execution time as well as the fault detection rate. The last objective is to evaluate the proposed approach on benchmark program and its applicability on case study systematically. Okay, literature review. Got 4 key areas, which is TCP approach, string metric, prioritization algorithm, and machine learning. For TCP approach, the related gap TCP approach does not adequately address on continuous changes. String-based, we got 6 base of approach: string-based, search-based, requirement-based, risk-based, and coverage-based. We choose string-based and search-based because of only these two does not rely highly dependent on on specific reference. For example, requirement based refer to highly dependent on requirement, while risk also highly dependent on the information about the risk, and then coverage effectiveness also highly dependent on coding, because coverage normally they will cover for the function. And then history based also history data live which may not available for numbers of software or project. So we choose string and search base because this tool does not highly dependent on specific data type. So summary from the study, there were quite a number of prioritization approach. String and search base seem to have advantage as both were not highly dependent on specific data or information, which is high dependency prone to continuous software changes. However, both approach does not work on targeted test case only, which requires some improvement. Okay, for string metric, uh, there is the related gap with is existing string approach highly dependent on single metric. So in TCP, the most used string metric it was the distance base. So there is two base of string metric. One is distance or simultaneous base. The second one is weighted string metric. For the distance base, the strategy was to differentiate between two or more information. In TCP context was the test cases difference. While for the weighted base, the strategy was to weight the information to give value or priority in TCP context is the test cases importance. So we got four string distance we chose, which is the basic one, Manhattan, Levenstein, Constantine, Yosemite, and Jacob. Each of them have their own advantage and disadvantages. So from the summary, all these four will be used in this research to be enhanced with one weighted based string metric. Also, the pass finding does not indicate any enhancement of string distance metric formulation with weight-based string metric. This implies an enhancement for string distance metric with other related metrics such as weight-based were worth for further analysis. So for prioritization algorithm, justification for the gap number 3, where to find a suitable algorithm which highly dependent with string metric to be integrated with enhanced string distance metric. So we choose nearest neighbor, beam search, and firefly algorithm. Each algorithm to be used in the research for as evaluation comparison. So based on the literature review on prioritization algorithm, all algorithms show quite promising FFD, but Beam and Firefly show good execution effectiveness. Firefly may have slight advantage because of its capability of fault detection as testing progress reported by Joseph. Also indicate that some intelligent algorithm may benefit in constant changes. For machine learning is related gap number 3 to find suitable machine learning with dependent with string metric to be integrated with enhanced string distance metric. So there is three major what we call type of machine learning, which is supervised, unsupervised, and reinforcement learning. While supervised can be divided into two: classification and regression. For unsupervised, clustering and dimension reduction. So for TCP, the data for TCP was unsupervised data. So therefore, we choose clustering for others classification for other type of machine learning technique. So there is several machine learning technique trending in recent years, and then classification technique in machine learning benefit from availability of historic data, which resulted in high FFD. However, to have like we said before, the historic data availability is quite low in dataset of TCP context. So clustering technique in machine do have performance wise compared to others, but still require improvement for TCP main objective, which is we need to find to get the higher FFD. While for reinforcement learning technique, application require more structured process and improvement to be able to be applied in standard study program. Because of most of the TCP dataset was not uh, very complete and not structured have complete structure of process. So for the research methodology, we got phase one, phase two. Phase one is research foundation and review to find the research gap. And then phase two is the design, the framework and experiment. We got the framework. And phase three is for experiment on data set. After we got the enhancing distance, and then we tune it, the enhancing distance into the clustering technique, tune it into the prioritization technique, and then we managed to get the enhanced clustering method, enhanced prioritization method, and then from these two we combine and then integrate it and then test it on data set, become our proposed test case prioritization approach. So currently I'm working on this stage because tuning, clustering, and tuning prioritization already been done. Okay, and then phase 4 is for research experiment on case study, and then phase 5 is completion. Okay, research framework, what have been done, we combine string metric distance, and then, for example, edit distance plus TF string metric quick base distance with TF ADF, enhanced together, we get enhanced string metric. And then from this enhanced string metric, we tune into these two algorithm, these two AI, which one is clustering, and then in the next one is precision algorithm, and then we get enhanced clustering method, and then we enhance precision method, and then these two we combine, apply into and integrate into proposed test case precision approach, which is using string, enhanced string, and then we test it with a benchmark program using Siemens, TCAS, GTCAS, STCAS, and Unix program, grep, gzip, and flex. And then we get prioritized test suite. We evaluate using, currently we're using APFD, coverage effectiveness, and time execution. The ANOVA is for the last one to uh, get the to make to verify the final result. So the evaluation method using APFD, coverage effectiveness, and ANOVA. For this is the example of calculation for APFD and the coverage effectiveness. And then benchmark program, we got one Siemens dataset, which is TCAS, GTCAS, STCAS, where this is actually for similar program but written in different program language, programming language. And then we got 41 version, different of test cases and different of form matrix. For Linux benchmark program, we use Flex, grep, and gzip. Flex, each of them have 6 version, number of spot, and then their test pool size. Because we choose a different size of test pool to verify the technique applicable on different size of data set. So chapter 4, enhance string distance with TF-IDF. So this is for the first objective, to propose and evaluate and enhance string metric in test case presentation by combining string distance and equate-based metric to increase spot detection rate and coverage effectiveness. So introduction, the enhanced string metric were developed in this chapter. Aim to solve the problem of lack of string metric priority, adding with element. The evaluation using Siemens dataset. So this is the experimental design. We start with the extracting the test cases from original and versioning program, extract the output data, and then we calculate the string distance times enhanced with the FIDF, and then we get the string test case distance metric, and then we prioritize, and then we calculate the APFT for the prioritized test case. Okay, how we enhance? Basically, this is the flow of the enhancement of string distance, where we got four string distance metric, and then we get one string weight base, which is TF IDF, where we split the TF and IDF to modify TF to get the different frequency for two test cases or document, and then we get the summation of the difference. And then after we modify this, when we combine that with IDF, and then this recombination will be enhanced with, we combine with, or we can integrate with the non-enhanced string distance. So finally, the final product, we got 4 enhanced string distance. Actually, this one is not just simply add or time. Actually, the idea is more like this. So we got one string distance. This one is called string distance. So for the string weights, the idea is giving the priority. So for weight, so the test cases should be maybe got higher priority or lower priority, higher priority or lower priority. So the modified string weight, the one that we modified the TF, to get the value difference between the priority between two test cases, and then the enhancing system we combine with string, and then we get the enhancing system between the actual different distance for these two test cases. So the result of the enhancing distance, so we can see here the one is the original Manhattan M, and then the enhanced one for the show improvement for almost all string, similar to CTCAS dataset, also similar to CS TCAS dataset. So the FFD result show that the enhanced one show better result for overall FFD rate. So while for the coverage effectiveness, the enhanced one, the enhanced string distance show significant improvement for coverage effectiveness. I see here, for example, for the percentage, the 1% of coverage effectiveness from 7% up to 60%. So it's very significant improvement. So therefore, for this significant improvement, we choose the MTF-ADF to be used for next two chapters. So the findings shows that the proposed enhanced string metric yield better result in terms of average FPFD and coverage effectiveness. Mutant key performance is the other name of evaluation metric for coverage effectiveness in TCP. The enhanced were better as the idea of rigging TMIDS have given an extra priority for each test case during prioritization and make an ideal complement. So the summary is we managed to cover our first situation and first objective, where and the outcome is enhancing system with the FIDF, which is the strength have given extra priority for each test case during partition, result in higher PFD result and coverage effectiveness. So chapter 5 is applied Firefly algorithm with enhanced string distance for TCP. So this part of objective 2, because part objective 2 we got clustering and prioritization. So we go for prioritization first, and to propose and evaluate prioritization method by tuning algorithm with enhanced string method to improve the execution time as well as the fault detection. So introduction, there will be used the enhanced string method distance, the one that we use, we highlight before, and then the non-enhanced also will be used, and then we got one TF-ADF. The aim to provide an applicability of both string enhanced and non-enhanced for Firefly algorithm, the applicability of SWAM intelligence in TCP and its performance. The evaluation were used using the real world Unix benchmark as well as similarity case dataset. So this is the applied Firefly algorithm, where we got Firefly component, Firefly agent, Firefly attributiveness, and distance between Firefly. And then we met with the TCP component, test cases, test case weight or uniqueness, while for test case distance, this one we use the enhancing distance metric. Each of them have their own justification, and then this is the we call flowchart for the Firefly algorithm. So the experiment flow is quite similar for the from previous chapter. We have this extracted dummy test cases, and then we calculate the agency metric between test cases, and then we prioritize it and calculate the result. So the overall result for this chapter, okay, we got benchmark program, Grab, Gzip, Flex, and TCAS. We got for mean FFD and time. This one is enhanced string distance, non-enhanced string distance. Then we apply Firefly. We compare with the most uses this Grady and GA in TCP. These two is the most used algorithm in TCP. And then LBS and PSO. This one is because of these two have similar or similar type of algorithm, or we can say that they belongs to swarm intelligence. So from this, the result we show that the mean FFD for all four this data set for enhanced string distance have higher result compared to other algorithm, as well as the non-enhanced strings. Okay, therefore the finding is show that FFD results show that FA may become some computer in TCP area because of FA managed to beat the most users algorithm, which is Greedy and GA. And then the enhanced string also show a good compatibility with some algorithm, which able to improve overall FFD result. In future work, it could be interesting to explore possible enhancement on this particular algorithm for focusing on coverage efficiency. Okay, summary is we managed to cover uh, part of objective 2 and part of resolution number 2, where the outcome is applied Firefly algorithm with enhanced string metric, and then the strength given extrapolated for each section during presentation and managed to improve the FFD result. So chapter 6, clustering technique using enhanced string metric for TCP. The other part of the objective 2 to propose and evaluate integration of clustering and prioritization technique with enhanced string metric to improve the coverage effectiveness as well as default detection. So introduction, in this chapter, we also use the similar string metric to be compared. And then there is two type clustering. There is the clustering. The type of clustering implementation used is clustering we using KNN, while prioritization algorithm we use Firefly algorithm. So the experiment is basically is extracting the test cases and then calculate the string value and then determine the test case or test software changes. And then determine targeted test case or the changes, and then clustering the test cases based on these changes, and then prioritize the test cases within the cluster, and then calculate the result. Okay, this is the overall result. Okay, overall mean FFD means that we get the FFD for overall software in the order for the overall what we call overall system or overall testing procedure. We show that non-clustered means that if you simply prioritize before cluster, the enhanced string will still have higher result. But because this is for the overall mean, so we focus on the main idea of clustering is to for the targeted edge cases, because of if let's say if there is only 10 function or 2 function have been changes. So we need to find the targeted test cases which is related to the changes. So the mean APFD for the targeted test cases for the clustered one has significantly improved compared to non-clustered. We can see here for TCAS, let's say if we targeted for only 2 or 3 changes, we got 95%, while non-clustered only 56%. Similar to coverage effectiveness for targeted test cases, and then we got 77% compared to non-clustered is 62% only. So the findings show that overall APFD result for clustering technique shows some declining value as the cases were divided into some clusters. However, the main purpose of this integration technique were to get the best APFD and coverage unit for targeted test cases, which is related to changes made only. So therefore, the result for both will significantly differ from the non-cluster technique. Therefore, it showed that the implementation of clustering in TCP managed to overcome the problem, which is to cater the targeted test cases in continuous changes environment. So the summary is we managed to complete the objective number 2 and resolution number 2. So the outcome is integrated of clustering and prioritization technique with enhanced string metric for TCP. The strength is the given cluster for targeted cases during the prioritization have managed to improve APFD and CE for the targeted cases. Finally, the conclusion, we got 3 contribution will be done, which is enhanced string metric, enhanced string plus Firefly algorithm, enhanced string plus clustering in TCP. So the next one is to combine all and then we come up with the detail of the process for the TCP approach using enhanced string approach plus clustering and prioritization. So the research progress, string enhancement completed, tuned with swarm intelligence completed. For tuning with machine learning, the experiment result already 90%, but writing still 25%. So in progress for combining both enhanced, we can total up these two, and enhanced clustering still 65% because of the writing. So list of publication, published journal, one TCP using Firefly algorithm for software testing. Q1, upcoming journal is machine learning technique in TCP, submitted status, and for next is clustering technique using enhanced string metric for TCP should be finished by end of this February. So that's all from me. Thank you. Any questions?
Thank you, Khatib, for sharing with us your research question. Now we will open the Q&A session if anyone has any question or comment on Khatib's research presentation.
Assalamualaikum warahmatullahi wabarakatuh. I'm Dayang. Khatib, your supervisor, jangan lupa.
Yeah.
I just want to ask you, it seems like you've been doing a lot of things, combining so many things together. Do you have any specific figures that you have in your presentation just now to really show what are the main problem that you will solve in this research, and what are the sub problem, and what you propose to solve the problem, and what measurement that you did in order to show the solution, to measure the solution of the problem. Do you have any particular slide that you can represent that the things that I described just now?
Okay. Actually, I don't have the exact any diagram or slide to address Dr. Dayang, Prof. Dayang questions. Basically, what I'm doing is maybe after this I will consider it to add a few more diagram. So what I've been doing is based on my based on my gap, first gap is to address the major one is to address the to find an approach to address the continuous changes because of nowadays software changes have been developed within in continuous changes environment. So in order to cater the problem, the conventional TCP does not have any some sort of focusing on some part of these cases only. Therefore, we need to what we call to
Okay, Khatib, can you describe what you introduced in order to close the gap 1, gap 2, and gap 3? Can
okay
you describe briefly?
okay for gap one. Okay, yeah. For gap one, I introduced an approach to get the what we call continuous changes. For gap two is what need to the string approach itself have only dependent on single string metric, which is uh, does not give what we call the exact value of distance between two test cases. So we enhance string metric for the gap one, and then the gap two. So for gap three is how to improve the prioritization for uh, the for the targeted test cases that we have been find. So in order to get the better precision technique, so to what we call to for the targeted test cases, so we need to either we cluster or classify which test cases belong to this belongs to these changes. So after we classify or cluster the test cases, then we can the prioritize the test cases. So the problem not using the classification technique because of we got most of the what we call data or data set for the TCP does not comes with the history information. So we go for the clustering technique.
Okay, so from what you show here, because it is a this is a PhD works, and there are so many things that you did in the works where you introduce different algorithm without a clear representation of the gaps, and then how you close the gap, and how actually you measure, saying that to conclude that you already solved the problem without a clear uh, presentation of that information. For me, it sounds like application, like you apply AI technique in software engineering. Okay, by doing, if that is the perception examiner have, the meaning that the application, it sounds like no contribution. Okay, so that's why I really emphasize on a good map or a good research framework where can address the major main problem, and then the 3 gaps that you have just now, and then what you propose in order to close the gap, and what you measure in order that you in order to say that you already closed the gap, and how you conclude toward the end of it you already solved the big problem, because the 3 gap is will conclude into one big research problem, right? So
Yes.
these are the things that you need to lay out, else because this is quite dangerous for those who's doing those who only apply soft computing technique into software engineering. Else it sounds like only application without any contribution. So as a software engineering research, we are looking at the contribution. One is looking at the contribution of how we solve software engineering problem, meaning that the solution that we propose is something unique that not been done by other researcher, or some improvement or enhancement on existing researcher way of we solve the problem. Okay, and then it's okay by applying certain soft computing technique, but as long as it's unique into the solution of software engineering, that should be fine. But look, because I'm joining the talk after my JCAS meeting just now in the middle, so I don't really see that how does it been documented properly. Okay, Khatib, but anyhow, if you can integrate all those three things, and then can address it directly to your main research question and how you conclude the problem, that should be appropriate for PhD. Okay, thank you.
Okay, thank you. Any more question or suggestion?
Anyone has any more question?
Okay, got it.
Okay.
Okay. Okay. For just one question. For the clustering technique, okay, you said that you propose the clustering technique, right? And then you go for the TCP. Okay. Is there any specific clustering criteria that you apply before you cluster the test cases?
Okay. For the clustering criteria, actually, because of back to here. Yeah. Okay. The experiment flow start with extracting test cases, and then we calculate the string value, which is enhanced and unenhanced, and then we determine the targeted test cases and or which related to the changes. So from here, the criteria is based on the changes, what kind of changes, and then which test cases are related to the changes. For example, so I don't have the data here. Okay, for example, we got the test cases. We got function number 1 and number 2 got changes for this version. So to test it, we find the test cases that are related to this function, and then we get the we find we get we focus on the test, go on the test cases, and then we focus on the value of or the input for the function 1 and function 2. So we consider the criteria is the input for the function 1 and function 2, which is the function that have been changes. So then we get the cluster of test cases, and then we prioritize the test cases within the cluster, and then we calculate the result.
The changes you mentioned is code changes or requirement changes?
Okay, for my experiment, since the data set only have the coding, test cases, and the fault data, so we don't have any requirement. So for my data set, I'm using the code changes, and then we map to the test cases, and code changes lah. For my cases, I'm using code changes.
Does it reflect to the requirement changes if you change the code?
Sorry?
Does it reflect the requirement changes if you change the code?
Okay, sometimes code will change. Code changes can be in some cases the code changes does not affect the requirement. For example, they need to make an improvement, some sort of flow or something. But normally, if there is a requirement changes, they will have a code changes. So if we uh, focus on code changes, so it will not have any problem if there any changes in the requirement, because if requirement change, the code definitely will change. But if code change, the requirement may not change, but the test cases will affect it also.
Okay, so in your research, you are focusing which changes?
Code.
Code, not requirement.
Uh, Sorry?
Code or requirements?
Code changes.
Okay. Okay, another one. Do you consider any requirement what you call it, requirements traceability? Okay, meaning that one cluster relate to another cluster and so on.
I'm not doing the traceability part, because if I'm doing the traceability part, it will be, my research will be too big already. So what I consider that the traceability has been done. So even for the within the data set, if they already trace if this changes. For example, if this code, this version function, this change, and then the which part of this case is affected, and what the fault or the data for the fault also change. So there is already traceability made within the data set, so I'm just using it. So because of, if I'm propose any traceability techniques, my research is gone too big already, and then it will be quite differ from the TCP itself.
Okay, one last question. Looks like you already did the experiment for clustering. So what is the future works after this? The
Okay,
future work.
future works. The future work is to recommended how the integration of the enhanced string distance, the integration of enhanced string distance with the clustering and the prioritization technique uh, to be applied for the TCP, to be considered as the enhanced the enhanced string based TCP approach. That's all.
Okay, regarding the Professor Dayang's comment, maybe you can refer my thesis. I'm not sure what chapter, but related to goal oriented. Apa entah. Nanti kata check lah.
Okay.
Based on Dr. Dayang's comment, meaning that you have major problem and then divide a number of research gap, and then how you solve it, what measurement you apply, and then and the last one, how you solve the major problem. You boleh refer my thesis after this. Okay, thank you.
Thank you. And
Any more questions? Okay, thank you, Prof. Dayang and Dr. Raham for the comment and question. So if there is nothing else, I think we can end up today's curriculum. Thank you all for your participation and see you in the next curriculum. You may leave the meeting now.
okay, thank you all.
Okay, thank you.